Well, hello everybody, and welcome back. We got a big, crazy topic called the unit circle today. It feels good to be back on the horse here, back doing an Algebra 2 trig video. We're going to crank out a few definitions here real quick and kind of set the stage for what's coming. But a unit circle, whoops, I got to get the right pen going here. Hold on, time out. Okay, I think I'm back. A unit circle is a circle with a radius of 1. Okay, that's the key right there. We've got a radius of 1, and that's basically called a unit radius. And what we're seeing here is that the word 1 and the word unit are pretty much synonymous with each other. They're interchangeable. So anytime you hear the word unit, I want you to instantly think 1. And that unit circle, it happens to be centered at the origin, which again is a very friendly idea that's going to make our life a lot easier. One more definition here before we really get the drawing our diagrams up. But for any generic random point, and we'll call it x, y, we want to keep it generic so that there's no specific numbers in it. If it's in the first quadrant, the lengths x and y become the legs of a right triangle. Whose hypotenuse is 1. Again, length of 1. So here's what we're going to draw a diagram here, and I want it to be large. I want it to take up half a page in your notebook here, and that's one of the things we'll be looking for as we come around and check tomorrow. But anyway, so we've got really big y-axis and a really big x-axis. Okay, and now we already said, the first thing we said was that the radius is 1 and that it's centered at the origin. So I'm going to go 1 unit to the right, and I'm going to label that point 1, 0. I'm going to go 1 unit north, that's 0, 1. 1 unit to the left, that's negative 1, 0. 1 unit down, 0, negative 1. And those four ordered pairs are going to be very, very valuable as we're going forward. And then I just want you to draw the nicest circle. Well, that's not bad for me. Sometimes they're a little uglier than that. The next thing I want you to do, let's go around the horn and just really quickly label our degrees. That first point we had, that's 0 degrees, and then up here is 90 degrees. We got 180 degrees. Down here we've got 270 degrees. And then wrap back around, 0 is the same thing as 360. They overlap with each other. Okay, now that we got all that labeled, here's where it gets really crazy. We talked about taking a generic point, x, y, and putting it in the first quadrant. Now, the key is that point has to fall on the unit circle, not inside it, not outside it, but right on it. And that generic point is going to be called x, y. And we said that the lengths x and y are going to form the legs of a right triangle. So it's almost like you started here at the origin, you went x units to the right, and then you went y units straight up. So x units to the right, y units straight up, and then we'll draw the hypotenuse. And we already said that the hypotenuse has a length of 1. And the reason that that's guaranteed is because this line right here is just another radius within the circle, and all of the radii are guaranteed to have a length of 1. Now, the next thing we want to label is this angle right here is called theta. All right, and that's theta in standard position. That's very important to understand that standard position means that the vertex is right on the origin. And so now what we're going to do is we're going to take a look here, and we're going to see if we can express the sine and cosine of that theta. So for beginners, let's say that the cosine of theta is equal to adjacent over hypotenuse, which in this case, adjacent is length x, and the hypotenuse has a length of 1, so we can clean this up and say that the cosine of theta is really just the length of side x. Also, we could say that the sine of theta is equal to the opposite over hypotenuse, which in this case opposite is length y, and clean that up and say sine of theta is simply just y. So let's go back up here to our ordered pair. And we could say that x is equivalent to the cosine of theta, and y is equivalent to the sine of theta. And that right there, ladies and gentlemen, is a monster discovery here on our part. And we want to put a real big box around that to highlight that this ordered pair is equivalent to this ordered pair right here. Okay, now I want to start with a new fresh diagram, okay, and this one could be rather large too. And we're just going to repeat everything we just drew. We've got our lengths of 1, okay? And we're coming around the horn here. Now this time, what I want to do is we're going to try to repeat everything we did just a little while earlier. Okay, that random point is XY again. We've got our right triangle. All right, let's label these points. Let's call this point right here, let's call that O. This point right here is called A. This point up here, let's give him a name, that's B. Hopefully you can read that. Now what we're going to do now is we're going to get a little sneaky here, and what we're going to do is we're going to extend that hypotenuse just a little bit further so that I could draw a line straight down, and I want to hit that dot right there. I want to draw the hypotenuse just long enough so that I can come straight down and hit this dot right here, and then we'll extend the base a little bit. And let's call this new point down here C, and this new point up here, we'll call that D. All right. Now, when you look at the red triangle, believe it or not, you already know one of the lengths. In fact, you know the length of the base right down here. The base, side OC, is just another radius in our circle. So I could say that the base has a length of 1 unit, just like the blue hypotenuse had a length of 1 unit over here. All right. Now, with all that being said, I want to now see if we could figure out the tangent. Whoa, let's see, that got kind of crazy. All right, stay right there. All right, can we figure out the tangent of theta? Now, tangent of theta is always opposite over adjacent. And one of the things we could do, if I looked at the blue triangle, it would be AB divided by AO. However, I don't really know the lengths of either one of those sides, so I'm going to stay away from the blue triangle, and I'm going to focus on the red triangle. And if I focus on the red triangle, it's going to be DC is going to be the opposite. CO is going to be the adjacent. And what's beautiful is we know that CO has a length of 1 because it's just the radius of the circle. So to summarize what we've just kind of discovered here, let's say in our notebook that the tangent of theta is equivalent to the length of side DC. Okay. The last one I want to try to tackle here is secant. See if we can discover anything about him. Now, the secant of theta is the reciprocal of cosine, so I'm thinking it has to be the hypotenuse divided by the adjacent. And we're going to cut right to the chase, and I want you to look at the red triangle only. Remember, our theta should be right there, and I forgot to draw it. That's very important. If you look at the red triangle, the hypotenuse is DO, and the adjacent is CO, and we know that CO has a length of 1, so we could simply say that the secant of theta is equivalent to the length of side DO, and that'll be true every time. The last thing I want to do is I just want to go over how to draw these diagrams if they move you to a different quadrant. Okay, what if they said you had to be in quadrant 2 and we wanted to draw this unit circle with a triangle inscribed in it? We always tell yourself that the triangle has to be firmly sitting on the x-axis. So now we'd put our generic point right here, and we would just drop straight down, and this is what the second quadrant drawing would look like. Again, we've got a length of x and a length of y, and our theta would be right there, and that would be the reference angle for this bigger angle over here. If they said something, if they wanted us in quadrant 3, now, instead of sitting on the x-axis, our triangle is going to be hanging from the x-axis, so to speak. Okay, we'll put our generic point right there, and we'll say, okay, now see how it's kind of like a sine almost, that this triangle's dangling or hanging from the x-axis. We'll put our theta right there. We've got a length of x and a length of y, and both of those sides should be negative. And then last but not least, if you're in the fourth quadrant and they want you to draw a triangle there, we've got our unit circle, we've got our generic point, xy, and then again we're kind of dangling, our triangle's dangling from the x-axis, and our theta would be right there. Well, here's our first example for today, a very typical problem that you could see on a quiz or a test, and they've given us this very overwhelming diagram. It's very cluttered, there's a whole lot of nonsense going on, but we're going to sift through it, and we're going to try to name a line segment that represents the given trig functions. And so the first one we're going to start with is the sine of x. And let's see, I want to pretend that my angle, I could say that even though they said theta's over here, I could say that theta is really right here because that's just the reference angle for that. And sine is opposite over hypotenuse. So I've got QS is the opposite. Ooh, can I draw that? QS. And then the hypotenuse would be QO. And what's beautiful is we know that QO has a length of 1 because we have the unit circle in play. How did you know it was the unit circle? Well, you'll notice it goes right through the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So we could say sine of x is really just QS, and that would be my final answer. Now, as far as cosine goes, that's adjacent over hypotenuse. Adjacent is going to be SO. Hypotenuse is again QO, and we know that QO is 1, so SO would be the final answer there. Now it's going to get a little trickier. Notice I was using the smaller of the two triangles there. When we start to have a discussion about tangent now, and that's the third example, tangent says we need to look at the bigger triangle, and that's going to be true every single time. I want you to focus right here on the bigger version. And when we're looking at tangent, it's going to be the opposite PR divided by adjacent RO. So let's go write PR divided by RO. Whoops, hang on. Okay, we've got PR divided by RO. The good news is RO, if you look at that diagram, has a length of 1, so we just get PR. Okay, that would be my final answer there. And then we've got to do secant, and secant's going to be the hypotenuse here divided by the adjacent here, and adjacent RO again is a radius, has a length of 1, so I'm just going to go with PO for my secant answer. All right. So hopefully that makes a little bit of sense. When in doubt, take your time. Just write your ratio, then fill in the two sides, and then typically, if we're doing it right, one of them should always have a length of 1 so that it simplifies really nice to a single side. Our second example is an extremely common question, especially on the Regents exam. And they said, what if point P with an ordered pair of negative 1/2 comma negative radical 3 over 2. Okay, those both are negative. What if that point falls on, and I want you to emphasize the word on big time. It's not inside the circle, it's not outside, it is right on the unit circle. And they're going to ask us what is the measure of angle theta. Okay, number one, a drawing is absolutely required on a problem like this. All right, we've got to be able to sketch this scenario. All right, we're going to have unit circles coming out of our ears pretty soon. And we got, we've got 1, 0. Up here we've got 0, 1. Over here we've got negative 1, 0. And down here we've got 0, negative 1. And now they said that point falls right on the unit circle. So I'm going to attempt to draw that point. And I'm going to go negative 1/2 and then down. We're just kind of approximating, and we know it falls on the circle, so we can safely put it right around there. We've got negative 1/2 negative radical 3 over 2. And then we know we've got to connect the legs here and draw our right triangle. Of course, our right angle's right there, then our theta's right there. Okay. Now, as far as finding the measure of angle theta, and actually what I drew here, theta is the reference angle for this bigger angle here that this is the angle they're asking for when we're all said and done. How are we going to set this up? Well, we know two fundamental things. The most important thing we put down in our notebook earlier was we made a statement that said the ordered pair x comma y is always equivalent, with regards to the unit circle anyway, to the cosine of theta comma sine of theta. And how do you remember this? Well, the good news is they're in alphabetical order. Okay, so let's make a little note there. They are in alphabetical order. For instance, x comes before y, c comes before the s, and they just fall into line. So what I could say here is, I could say that the cosine of theta is really equal to negative 1/2. I could also say that the sine of theta is equal to negative radical 3 over 2, because that was the y-coordinate they gave me. And what I'm going to do is I'm going to focus on just one of these for right now. All right, think of the flashcards we've made. When does cosine equal 1/2? We could say that the reference angle is 60 degrees, because the cosine of 60 does equal 1/2. And then because it's negative, that just means we're not in quadrant 1 or 4. So what if that little gap right here was 60? How big then would the entire angle be? So I'm going to do 180 plus 60 and say that 180 plus 60 represents 240 degrees. All right, and then I'm just going to I think that's the answer. Now I'm just going to check it over here, and I'm going to ask myself, when does do I have a flashcard that says that the sine of theta is radical 3 over 2? And I say, yeah, that's true whenever theta is equal to 60 degrees again. It should be the same, and it is. So again, we're just saying that the reference angle is 60. We add the 180 to it to push it into the third quadrant, and again, we get 240 as a confirmation. And so we can say with confidence that this entire angle here, the big whole angle, is 240 degrees. Do me a favor when you're doing a problem like that. As you're drawing it, we all know that this guy right here is 180 degrees. We all know that this rascal down here is 270. Tell yourself right away that my answer has to be somewhere between 180 and 270. Otherwise, we know we did something terribly wrong, and that's kind of our red flag to catch any mistakes. Our third question here is almost exactly the same as the last problem, but it's worded a lot differently, and that's what I wanted to expose you to, the different wording. But it says this ordered pair, 0.6 comma negative 0.8, represents a point where the terminal side of theta intersects the unit circle. Okay, and that's the key, intersects the unit circle. And I want you to instantly start drawing. Okay, we've got our unit circle here, and we're going to kind of approximate where the 0.6 and the negative 0.8 are. We could say that we're going to the right 0.6 and then down 0.8, and it's going to be right there. The key, again, though, is that this dot that you plant needs to be right on it, okay? Because how do you know that? Well, they said the theta intersects the unit circle at that point. So there's our terminal ray. Here's our initial ray right here, and the angle goes this way. And then, of course, this theta here would be his reference angle. All right, we're going to drop this line straight down to form our right triangle. We know that this has a length of 0.6. We know that this side has a length of negative 0.8. And, of course, the hypotenuse has a length of 1 because it's in the unit circle. So that goes without saying. Again, they want me to find the measure of angle theta. So there's two things that I want to see you write down on your paper right away on a problem like this. The first thing is we know for sure that the cosine of theta is equivalent to 0.6. We also know that the sine of theta is equivalent to negative 0.8. So what I'm going to do, now this 0.6 was never on my flashcard, so for this one I have to pick up my calculator and I'm going to solve for theta. And anytime you're solving for theta, we're going to use the inverse cosine button. We're going to say that theta is really the inverse cosine of 0.6. I'm going to make sure, as long as I'm in degree mode, I could strictly type that right into my calculator. And as I did that, my calculator gave me about 53.13 degrees. So I'm going to round that off to about 53 degrees here. Now the trick is that's not my final answer. Now remember, that is just the reference angle. So 53 is telling me how big this gap here is. And then they're actually asking for the big primary angle there. So all I'm going to do is I'm going to subtract 360. I'm going to do 360 minus 53, and that's going to tell me how much is left over. And let's see, that's going to turn out to be about 307 degrees. And looking at my picture, that totally makes sense that 307 is a viable answer. Again, I made a note to myself that my answer should be somewhere between 270 and 360. And if it's not within that interval, I know I did something wrong. Now over here, as a way of checking it, I'm going to say theta is the inverse sine of, catch this, 0.8. When I do the inverse part on the calculator, I never use the negative, so that might be worth making an extra note on. And as I do that, the inverse sine of 0.8, the calculator again says 53. That represents the reference angle. That represents the gap right here. And again, we subtract it from 360 to get 307. So we've confirmed that that is indeed our answer. All right, here's our next question. They're asking me to find all values of theta that satisfy the equation or the condition cosine of theta is equal to 0, where theta can be any angle within the interval 0 to 360. Now, I want you to really focus on the fact that look at those inequality signs right here. This inequality sign includes the 0 because of the equals to sign, but then this second one does not include the 360. It's not equal to. So if you get a solution of 0, you're allowed to keep it, but if you get a solution of 360, we're going to have to throw it away because it's not within that interval. Anyway, what I want you to do for a trick like this, anytime you get a 0 or a 1 or a negative 1 right there, okay, those are the special cases. Anytime you get a 0, a 1, or a negative 1, okay, right here, I want you to instantly draw your unit circle, and I want you to label those 4 special points. We've got our 1, 0, we've got our 0, 1. We'll label them just as fast as we can. And again, we're going to have unit circles coming out of our ears, and we're going to do this many, many, many times. Now, the first thing that struck me is that when they said the cosine of theta is equal to 0, cosine is equivalent to x. on the unit circle. That's true every time. So I just substituted an x for cosine, and I asked myself, when is the x coordinate equal to 0? And I said there are two different moments. There's one right here where the x coordinate's 0, and then there's another one down here where the x coordinate's 0. So I would say there's two solutions. This one up here is 90 degrees. This one down here is 270, and that's it. My two solutions are 90 degrees and 270 degrees. And of course, you could type those into your calculator if you want to check them. You could type in the cosine of 90, hit enter, you'll get 0. You could type in the cosine of 270, again, hit enter, and you'll get 0 as a way of confirming your answers. Okay, our last one for the night is very similar to the one we just completed, and they're asking for all values of theta that satisfy the condition sine of theta equals -1 within the same interval. And again, we tried to say, okay, anytime you get a 0, a 1, or a -1 right here, I want you to instantly go draw your unit circle and label those 4 special points. Hopefully your circles are looking a little bit neater than they were at the beginning. And let's see, up here we've got 0, 1, over here we've got -1, 0, and down here we've got 0, -1. So as soon as they said that the sine of theta was equal to -1, I recalled that on the unit circle, the sine of theta is always equivalent to the y-coordinate. That's just one of our big rules. So I'm asking myself, where on this circle are the y-coordinates equal to -1? And I said, let's see, not there, the y-coordinate's 0. Up here, the y-coordinate's +1. Over here, the y-coordinate's 0. But down here, I got a winner, winner, chicken dinner. We've got a y-coordinate of -1 right there. So this time, we only have one solution. Last time we had 2. Sometimes you'll only have 1. And I'm going to say that angle right there is 270 degrees. So my only solution is 270 degrees. And again, if you want to check that answer, you can grab your calculator and type in sine of 270. And when you hit enter, hopefully you'll see -1. Now, before I leave you for the night, I want you to really remember the most important thing you need to walk into class with tomorrow is knowing that the coordinate x comma y is equivalent to the cosine of theta comma sine of theta, and that's true every single time that you're on the unit circle. Okay? Well, hope you took good notes, hope you worked hard, and we will see you tomorrow.